In this video, we're gonna learn how to solve a quadratic equation using all four methods. So before we talk about the methods, let's talk about the basics. A equation of the form, so we can see a quadratic equation, quadratic equation has the form ax squared plus bx plus c equals 0, where a, b, c are constants, where a, b, and c are constants with a not equal to 0, because if a equals 0, it is not a quadratic equation. And also the number 2 is what we normally call the degree. So this is a degree 2 polynomial, if you want to say it like that. So it's a degree 2. So degree equals to 2 in this case. And then this is also what we call the standard form. So if you have equation in this form, we call this is in the standard form. So this is in standard form. So we call standard form. Standard form means we have a square term is the first one, and then the x term, and then the constant term. So sometimes it's also important to write in the standard form later. We can talk about that. So let's look at some examples. So we have, let's say, the first one, 2x squared minus 3x plus 4 equals 0. So you can see this is a quadratic equation and also in the standard form. So, so you can see is quadratic in x, because x is the variable. Also let's look at this one. Let's say we have negative 1/2 t squared and then plus 10t plus 5 equals 0. So you can see this is quadratic in t, because the t is the variable. So we don't use x always, so you can see different variables. So the second one is in quadratic in t. And then we can also have, how about this one, negative 3x squared plus 7 equal 2x. So you can see this is slightly different. It's not in the standard form. So what we normally do is we're going to bring all the terms to one side first to make it to bring it to the standard form. So we can write this one as negative 3x squared, and you subtract 2x from both sides. So that means you can write this one as negative 2x, because bring the term to the other side, and then plus 7 equals 0. So now it is in a standard form. You can see x squared term and the x term and the constant term. And also sometimes what we do, we can also remove those extra negative signs. So if you divide by negative 1, you can bring, so if you divide it by negative 1, you can write this one as 3x squared plus 2x minus 7. So that's what happens when you divide by negative 1, is switch the sign. You can see that the second one is much easy. So compared to the first one, the second one is much easier to work with, because they have the plus sign, so it's easy to work with. So sometimes we do that. So you can always multiply or divide by a constant to bring it to a simple form. So the second one is much simpler than the first one. So we do that before we do any kind of calculations, any kind of process, we do that just to make it simple. Okay, so how about one more? How about this one? Let's say d, let's say negative 8 plus 7t squared plus 5t equals 0. And you can see that you have all the terms, but they are not in the standard form. So we rearrange the terms Like for example, you can write 70 squared first, and then we write the t term, and then we write minus 8. So now we bring it to the standard form. So we do that before we do any calculations. So that's something we have to remember. Okay. So next, what we mean by a solution. So, so we can say solutions of an equation. Solutions of an equation. So if you have an equation, so like for example, we can say x equal to is a solution. X equal to is a solution of the equation. Solution of the equation. You can say 3x squared minus 8x plus 4 equals 0. So there should be some equal sign here and equal something. So we say that x equal to is a solution of an equation. So what does that mean? That means when you plug in the value x equal to, it should satisfy the equation. So let's see whether that's the case. So the question is, so you can see why this is true, and you can see that x equal to satisfies x equal to satisfies the equation satisfies the equation So to check that, what we can do, we can substitute that value. So to check that substitute x equal to into the equation. Okay, into the equation. That's what I do anytime. So if you want to check something, whether something is a solution, just plug in the value to the equation. So we can do that. So that means if you plug in the value to the equation, you're going to get, you can see that you're going to get 3, and then it is the value is 2, so 2 squared minus 8 times 2 plus 4. So let's simplify. So we can check whether you get 0. So from the first, you're going to get 12. So you can get 12, and then minus 8 times 16 plus 4, and you can see that you're going to get 0. So that means that's exactly what is on the right hand side of the equation. So that means this is true. So that means it satisfies the equation. So that is how you know whether this is a solution. The question is, how do you know whether 2 is a solution? That's exactly what we're trying to do in this one. We're going to find out how to find those values, how to get these values. And also there's one more question. How do you know that is the only solution, whether there are more solutions? So we're going to answer both questions in this one. So there's a how to find it, and how do you know that there are more than one solution. So in theory, what we say is that solving an equation in general, solving an equation means finding all the solutions, finding all the solutions, and also if any, because sometimes there are some equations there are no solutions, if any. Okay, so that's what we mean by solving an equation. So let's see how we can do it. You can solve a quadratic equation in 4 different ways. A quadratic equation can be solved in 4 different ways. First, we can use the factoring method, and then the square root method, and completing square method, and the quadratic formula. So the most common ones are the factoring method and the quadratic formula, the first and the fourth one. So let's see one by one. So we have factoring methods. So let's look at the steps. So we have 3 steps. So the first one is move terms to the left hand side. Move terms to the left hand side. And then what we do, we factor. The second step, factor And then third step is set each factor equal to 0. So set each factor equal to 0 and then solve for x. Solve for x. So that's the general steps used in the factoring method. So let's say we have an equation like this. So let's say we have ax squared plus bx plus c equals 0. So what we're going to do is, so this is like quadratic. So that means there are two terms. So what we can do, we're going to factor this into two terms. So we're going to factor the first one. So you have a number and then x plus another number. That's the first bracket. And we have another one like that. So we have a number and then x plus another number. So this is equal to 0. So that's what we're trying to do. So we're going to factor into 2. So, and then we know that the numbers goes as the first term are the factors of a. So these are the factors of a, factors of the first term. And then the other numbers, so so these two, the constant terms are the factors of, so these are the factors of the constant term c. So that's the factors of the constant term c. So that's how we trying to find the factors. So what we can normally do is we're gonna find the factors of a and b so that so we're gonna factors and so that we get the constant term bx. We get the middle term bx. So we're trying to do so that we get the middle term. We get the middle term bx. So we're going to find factors of a and factors of c so that we get the middle term bx. That's the whole process. So we sometimes use a trial and error argument for this one. So we can use a trial and error argument so that you get the bx term, and that can be really time consuming. But we can discuss a different method to get the answer quickly. So let's look at some examples. Solve the following equations. So let's say the first one, x squared minus x minus 6 equals 0. So rather than using a trial and error argument, we can look at a systematic method. We can look at the constant term and we can look for two factors that's can added up to the coefficient of the middle term. So the coefficient of the middle term is -1. So we look for two factors that's can added up to the coefficient of the middle term. And also we since we have a negative sign, we're gonna put the negative sign because there's a sign of the constant term. That's the sign of the coefficient of the middle term to the larger one. What does that mean is two factors are one option is -6 and 1. So you can see we put the negative sign to the larger one. That's how we do. And then you can see when you add, you get -5, and that's not an option. That doesn't give you the coefficient of the middle term. So you can see at the numbers that works is -4 and 3, because you can see when you add them, you're gonna get -1, and that works. So that means since we know those two numbers, that exactly goes there. So that means you can write this one as x minus the first number and then x plus the other number. So you can see those are exactly the factors. So it's very easy. Once you find the right option, those numbers directly go there. And then what we can do is, so we factor it. That's a factorization. And then according to the argument, what we can do, we can set each factor equal to 0. So you can see x -4, x minus 4 equals 0. Or because we know this is a product. If the product is 0, we don't know exactly which one is 0. So that's why we're going to use the word or, because we don't know which one, but we know that one of them has to be 0. So we're going to say or x plus 3 equals 0. And then adding 4 to both sides from the first one, you can see that you're going to get x equals 4. And then or, and then subtracting 3 from both sides, you can see x equal -3, and you can see those are the two solutions of the equation, because once you plug in those values, then you can see that it works. It satisfies the equation as we discussed earlier. Okay, so let's look at the next problem. Um, how about this one? So we use the variable t now. So t squared plus 8t plus 16 equals 0. So we use a similar argument. Look at the constant term, which is 16, and then think of two factors of 16 that's going to add it up to 8. So we're looking for, and you can see those two numbers are 4 and 4, because you know that the 4 and 4 added to 8. If you add them, you get 8. So that's the right choice. So that means we can write this one as t plus 4, that's the first number, and then also t plus 4 equal 0. You can write this one as t plus 4 squared equals 0. And then when we get things like that, we normally call this is a repeated factor, because we have a 2 here. So we call this is a repeated factor. Repeated factor. So if you have a repeated factor, it's also give you repeated solutions, because the solution repeats. Now we normally call this is a double root, because there's a 2 here. Good. So in this case, you don't want to set both equal to 0, because there's only one. So we're going to set only one of them equal to 0, equals 0, and then this says that t equal, if you subtract 4 from both sides, t equal -4. And we normally call this is with multiplicity. So this 2 is called the multiplicity. How many times it repeats? So we say multiplicity 2. So with multiplicity 2, with multiplicity 2. That's the number, how many times you can repeat. So it's 2 in this case. Okay, that's how you solve the problem using the factor method. So let's look at one more example. Let's say we have 12x squared minus 6 equal x. So there are two problems here. So one is, this is not in the standard form. So first, by subtracting x, we can write this one as 12x squared minus x minus 6 equals 0. Now it is in the standard form. So the next problem is, the coefficient of x squared is not 1. So that means what we're going to do is we're going to think of factors of 12. So the factors of 12 are 12 times 1, and then 6 times 2, and then 4 times 3. So there are a lot of factors. And also -6, the constant term, also has so many factors. So for example, you can write this one as -6 times 1, and then 6 times -1, and then 4 times -3, and then -4 times 3. So there are a lot of options. So now what we can do is, in general, we can use a trial and error argument. So in general, so can use a trial and error argument, trial and error method. So can use a trial and error method to find which factor is going to work. So there are a lot of options, which factor is going to give you the middle term. So we check which one gives the middle term. So trying this, but we can use a different argument. So we can use the what we call the magic factorization. So we use magic factorization, or the systematic argument. So magic factorization. If you are not familiar with that, you can see a link in the description, and you can find what we do there. So, but let's just do one example just to figure out how it works. This is a straightforward argument. So what we normally do, so let's start with the problem. So we have 12 x squared minus x minus 6 equals 0. So what we normally do is we just follow the same argument as we normally would do. So we're going to first look at the product of the leading coefficient and the constant term. So in this case, you have 12 times negative 6, which gonna give you negative 72, and then think of two factors that's gonna add it up to the coefficient of the middle term. So in this case, negative 1. So what two factors going to add it up to the coefficient of the middle term? And you can see it is negative 9 times 8. So negative 9 times 8 going to add it up to the middle term, middle coefficient, which is negative 1. So that part is done. Now what we're going to do, we're going to think of two factors that is going to divide these two numbers evenly. Like you can think of two factors of 12, and for example, if you get 12 times 1, and you can see that it's not going to work because 12 1 divide both, but 12 does not evenly divide those two numbers. So that means we do not use that option. And the same thing happens with 6 and 2. If you look at 6 and 2, and you can see 2 divide 8, but 6 do not divide negative 9 evenly. So we do not go for that option. So the best option would be 3 times 4. So if you go 3 times 4, you can see 3 divide negative 9 evenly, and also 4 divide 8 evenly. So those are the options we are going to pick. That means we can write the factorization directly like this. So we can write this one as now. One is 3x, that's the first number. The other number is 4x. Other term is 4x. Now to find the other term, and then we set this equals 0. What we can do, we simply get the numbers from here. So you can see, to get the other number, what we can do to find this number, what we can do, we can divide negative 9 by 3. So that's exactly the number goes there. So this is negative 3. And then to find the number for the other term, we just use the other one. So that means this number here is 8 divided by 4. That means plus 2 is the other number. So that works straightforward, and it's not trial and error argument. You directly get the solution from this method. This is what we call the magic factorization method. So you can find the link in the description if you are not familiar with this method. Good. So now since we have the two factors, we do as we did before. So we can set each factor equal to 0. So 3x plus 2 equals 0, or 4x minus 3 equals 0. 4x minus 3 equals 0. And this is very to simplify. You're gonna subtract 2 from both sides and then divide by 3. So you're gonna get negative 2/3. That's the first solution. The other solution is similarly to 4x equal 3. If you divide by 4, so x equal 3/4. That's the other solution. So this is how we use the magic factorization argument when the leading coefficient is not 1. And you can see, if you just use a trial and error argument, it's going to take a lot of time because there are a lot of options, but this one going to give you the solution straightforward. Okay, so let's go to the next method. So next method is what we call the square root method. Square root method. So what we can do here is, so if you see that if x squared equal to d, a number with d greater than 0, it's actually greater than or equal 0, then what we can do is, then you can take the square root. So x is simply plus or minus square root of d. So that is the square root method. This is a straightforward argument, but there are plus or minus, so we need to exaggerate that. So you can see that why this is the case. For example, let's say we have x squared equal 4. If x squared equal 4, and you can see that there are two solutions to this problem. You can see x equal 2 and x equal minus 2 both works. So how to get those two solutions? That means just when you take the square root, it is plus or minus 2. 2 is simply the square root of 4. That's where the 2 coming from. That is the square root 4. That's the exact same argument we use here. So that means if you have x squared equal d, the solutions are x equal plus or minus square root d. And for this one, d has to be greater than or equal to 0. But if d equals 0, you do not get two solutions, you only get one solution. So you have to be careful with that. And then we're going to consider d negative case later. So let's look at some examples now. So let's say solve the equations. So let's say look at the first one, 3x squared equals 60. So you can see that this is not exactly in the form x squared equal d. So what we can do, we can divide both sides by 3 first. And once you do that, you can write this one as x squared equal 20. And you can see now this is in the form that the square root form. So that means we take the square root of both sides. So x equal plus or minus square root 20. Now the question is, can you simplify this one? And you can see that yes, you can simplify this one. The reason is 20 you can write as 4 times 5. So what we're trying to do, you try to write the number using the largest possible complete square. So this is a complete square. Complete square. So what you're trying to do, you try to write using the largest possible complete square. So what are the complete squares? So you can see 0 squared, which is 1, and then 1 squared, which is 1. Actually 0 squared, which is 0, which is 0 squared, which is 0. And then 1 squared, which is 1. And then we have 2 squared, which is 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. And then 9 squared, which is 81, and 10 squared, which is 100. So those things would be helpful when you solve problems like that. So you can see in this case the largest possible complete square that you can use is 4. So we use 4 in this problem. That's what you do, and then take the square root of both numbers. So once you take the square root, and then you can see what happen now when you take the square root. So when you take the square root, you take the square root of each term. So square root of 4, which is 2, and square root of 5 we don't know, so we write it like that. So we write this as a irrational number, so we can write it like that. It's not like a integer, so we write it like that. So now you can write the final answer plus or minus using this 2 square root 5. So that is the benefit of using that technique. So we write using a complete square and then take the square root of each term. So square root of 4 means 2, square root of 5 means square root 5. We just leave it like that. Okay, so that's how we do it. So let's look at one more problem. Part B. How about this one? Let's say you have x plus 5 squared plus 3 equals 17. So you can see that this is not exactly the form because we have some extra terms. So what we do as the first thing, we're going to move this plus 3 to the other side. I mean, we're going to subtract plus 3 from both sides. So you can write this one as x plus 5 squared. If you subtract 3 from both sides, it's going to be 14. 14 means 17 minus 3. Now you can see, you can take the square root of both sides as before. So once you take the square root, so you can see this one as x plus 5 equal plus or minus again square root of 14. You can get that. But the thing is that square root of 14 you cannot simplify that further than that, because square root of 14 there's no largest possible factor you can out, largest possible complete square that you can take out. So we leave it like that because 14 is you know that is 2 times 7. So you cannot find any complete squares there. So we leave it like that. And then only thing what we can do is subtract 5 from both sides. So then you can write this one as x equal, if you subtract 5, so it's negative 5 plus or minus square root 14. So that is how you can write the solution. Good. So now the question is, so if you have this form, like if you have a x plus 5 squared kind of terms, we know what to do. But now the question is where that is coming from. So that part we can answer in the next method, that is the completing square method. So let's talk about the next method, completing square argument. The completing square method based on a special identity that we know in algebra. So we know that if you have a plus b whole thing squared, which simply equals to a plus b times a plus b, and we know that this simplifies to a squared plus, and then we have 2ab. So because you're going to get the ab term twice, You get the AB term by AB and then this AB. So these are all going to give you AB terms. There are two of them. And then the last term is B squared. What we can do, we can rearrange this term in like a interesting way. What we can do, we can write this one as A squared, and then I'm gonna put 2B together, 2B, and then A plus B squared. So we write B squared. Why we do that? Because you can see a pattern here, and you can see that this B is simply half of this. You can see that B is half of the coefficient of A. So this is simply half. And that always happens because it doesn't matter what the B is, it's always the half of 2B. Because we know the B is simply half of 2B. If you divide 2B into half, you get B. So that is the argument we're going to use now. We see that it is always the half of the coefficient of A. Because the 2B is, we call the coefficient of A. Coefficient means the number in front is called the coefficient. So we can use this as the major argument for completing square, because this is always the case. So what we're going to do now is we can look at the general case. So let's say we have x plus, so we can look for that special term x plus, we can look for the special term, so I'll have a space here, equal. So what we're going to do, instead of A, we put x here. So let's write it in this form. So let's say we have x squared. Let's say we have the term bx. So b can be any positive, negative, or zero number. But we argue that the other term, the constant term, is simply half of this b. It's always half of this b. So that means it's going to be b over 2 squared, because it doesn't really matter what we had, it always has to be half of that. And then you can see that's exactly the term goes to the inside the parenthesis here. So we can write this one as a complete square. So that means this term is always half of b. So that means that term appear in two places. So it's always so actually we can write this one to be better if you write it like this. So this is b over 2 always. So this is the completing square formula. So that means what we're going to do is we're going to take half of the coefficient of x. If you take the half of the coefficient of x, and you can see this side is simply become a complete square. So you can see this is a complete square. Complete square. And then this special term here is you can see that there's a square of half of the coefficient of x, square of half of the coefficient. That means the number in front of x is the coefficient of x. That's always the case, because this is the formula we can use. That's always the case. You take the half of the coefficient of x and the square, and that is the special term that we can add to make the left hand side a complete square. And then what goes inside is always half b. B over 2 always go inside, and b carries the sign. If it's a positive, go positive. If it's a negative, go negative. Okay, so let's look at the steps now. So these are the steps that we're going to use to solve a problem using the complete square method. Completing square method has these steps. So there are 6 steps. So first we do move the constant term to the left hand side, and then factor out the constant, the leading coefficient, like a, if a is not equal to 1, and then we add the special term b over 2 square to both sides. We normally call this the magic term, because that's going to change the expression to a complete square. So we normally call this a magic term, because that's going to change the expression. That's b over 2 square. B is the coefficient of the x term. And then write the left hand side as a complete square, because that's automatically that happens always, because when you add the b over 2 square term, this always happen. Write the left hand side as a complete square. That's always the case. And then also simplify the right hand side. You have to simplify that side. And then we have the extra step. If you factor out, in this time we're going to divide by that. So that's the extra step depending on whether a is equal to 1 or not. So divide by a. So we can divide by a in this time. And then after you divide, we can take the square root of both sides and then solve for x. So those are the 6 steps to do the completing square method. So let's look at several examples now. Solve using the completing square method. So let's look at the first problem. Let's say we have x squared plus 6x equals 0. So you can see that there's no constant term. So what is the special term that we're going to add here? So you can see the leading the constant, the coefficient of the x term, that's b, which is 6. So we divide that term by 2 and a square. So that means which is 9. So 9 is the special term that we can add. So add, you can see adding 6 over 2 squared, which is equal to 9, to both sides. Why we do that? Because when you do that, that is a special term that you need to add to the left hand side to make it a complete square. That's a special term. It's always the case. So you can see we're going to get x squared plus 6x plus 9 this side. In the other side is simply become 9 because they have a 0 there. Now when you do that, left hand side is automatically a complete square, and that's the whole reason why we add that. So this side is x plus, and then you take the half of this term. That's always goes here, half of that. So that means which is 3. So let's add a half of that. So which is 3 squared. That's a half of 6. That's a half of 6. Equal on the other side, which is 9. Now you can use a square root method. So just take the square root of both sides. So once you take the square root of both sides, is x plus 3 equal, this is square root of 9, but this you can simplify. This is square root, so plus or minus is 3 because square root of 9 is 3. Okay, now to isolate the x term, what we're going to do now is we're going to add 3 to both sides. So we just follow those 6 steps now. And we didn't have to factor out because a equal 1. So we'll subtract 3 from both sides. So you're going to see 3 plus or minus 3. Now we consider 1 by 1. So if you consider the plus sign, you can see you get x equals 0. And if you use the minus sign, you get x equal negative 6. So those are the two answers. So this is the completing square method. Let's see what happens if you use the factoring argument and whether we get the same answer. You should, but let's see. So factor method, just in case. So let's see how it works. So we have x squared plus 6x equals 0. So you can see x is a common factor. We're going to take it out. So you can see x plus 6 equals 0. This one you can write as x minus 0. It's an exaggeration. And x plus 6 equals 0. So if you set each factor equal to 0, you can see x equals 0, or x plus 6 equals 0. And then this says that is again x equals 0, or x equal negative 6. And you can see that's exactly the two answers we get. Actually, here we're gonna get x minus 0 equals 0. So it's different. Okay, so you can see it's the same, but that's how the completing square argument works. So let's look at a few more examples now. We have x squared minus 8x plus 1 equals 0. So what we can do, first step is we're going to move the constant term to the other side as the first step. So we have x squared minus 8x equal negative 1. Okay, move 1 to the other side. Now we're going to find the special term, and you can see the special term is negative 8 divided by 2 squared. That's the special term. So which is negative 4 squared and you can see which is 16. So 16 is a special number that we can have. So adding negative 8 over 2 squared 16 to both sides. We're gonna have x squared minus 8x plus 16, and do the same thing on the other side as well. So 16 to both sides. Now you can see this side is automatically a complete square, which is x minus 4. Why? That's the half of negative 8. It's a half of negative 8. And then the other side, which is, you can see 15. Now we can take this square. Now we can take the square root of both sides. When you take the square root of both sides, you can see x minus 4 equal plus or minus square root 15. And then we add 4 to both sides. When you add 4 to both sides, you can see 4 plus or minus square root 15. And you can see square root 15 you can simplify. So that is the final answer for this problem. So let's look at the next one. Let's say we have negative 3t squared plus 12t plus 17 equals 0. And when you look at this problem, and you can see that the leading coefficient is not 1. So that means we have to use the factoring argument. So what we're going to do, we're going to factor that out. So that means t squared. Factor out means you divide the terms by that. So you divide by negative 3, so you're going to get that. And if you divide 12 by negative 3, you're going to get negative 4t. And then what we do, we leave a space here, and then we move the constant term to the other side. So we move the constant term to the other side and factor out a negative 3. Now we're going to find the special term. And you can see this is the coefficient of the t term. So we're going to the half of that. So it is negative 4 over 2 squared. So you can see which is 4. So you're going to add 4. So you're going to see plus 4. But when you add 4, you are not really adding 4. You are adding the product here. So it is negative 3 times 4. That means you are adding negative 12. So it is negative 12. Because you have to add the product. It's not just 4. It's 4 times negative 3. So it's negative 12. So this negative 12 is negative 3 times 4. Good. Now we can simplify this. And then what happened now is this simply going to be negative 3 times. This is t. And the half of the coefficient, which is negative 2 squared. That's automatically on this side. The other side is negative 29. Now what we can do, we can divide both sides by the constant term, leading coefficient. So that if you divide by negative 3, you're going to get this is negative 2 whole thing squared equal negative 29 over negative 3. So which is 29 over 3. Now we take the square root of both sides. So taking square root. Taking square roots. You can write this one as t minus 2 equal plus or minus 29 over 3 square root. And then if you add 2 to both sides, so t equal, if you add 2, so 2 plus or minus 29 over 3 square root. So that's exactly the answer you're going to get for this problem. And you can see these are the major steps that you need to do for this one. So there are in general 6 steps. Good. So let's look at the last type. That's the quadratic formula. So quadratic formula. So we're going to write the quadratic formula without the derivation, but you can find the derivation in the description. So there's a small video on how to derive the formula. But here we write the formula without derivation. So the solutions. So the solutions of the quadratic equation ax squared plus bx plus c equals 0 without a being 0 are given by the quadratic formula are given by the quadratic formula formula. This is something you have to remember. They are given by the quadratic formula, and how we write it? It is x equal negative b plus or minus, there are two solutions, plus or minus b squared minus 4ac, and you can see all abc are in this one, and take the square root of this term and then divide the whole thing, this everything, by 2 times a. So that is what we call the quadratic formula, and this is only valid when a not equal to 0, because you are dividing by 0 otherwise. Okay, so this is what we call the quadratic formula. So this is something you have to remember. So negative b plus or minus square root of b squared minus 4ac, and everything divided by 2a. And then where the delta, this delta is called, like delta, which is b squared minus 4ac, is called the discriminant, is called the discriminant. We call this is the discriminant, because that's going to decide whether the solutions, whether there are solutions, whether there are real solutions. So we check the sign of this one. This is what we call the discriminant, b squared minus 4ac, without the square root sign. We call the discriminant, and that's going to decide the nature of the solution. Okay, so decides the nature of solutions. So there are 3 types to consider, depending on whether the discriminant is positive, or discriminant is 0, or discriminant is negative. So let's look at those 3 cases separately. So there are 3 cases to consider. There are 3 cases. So let's go one by one. So the first one, if the delta b squared minus 4ac greater than 0. If it is greater than 0, what happens? There are 2 distinct real solutions. There are 2 distinct, but they are not equal, they are different. There are 2 distinct real solutions. 2 distinct real solutions. We can call it R1 and R2. So let's call them R1 and R2. So then what happened in this case, since there are 2 solutions, what happened at those solutions, those are actually the x-intercepts. So what happened in this case, you can first write your equation in these forms. You can write this one as ax squared plus bx plus c equal a times x minus r1 and x minus r2. So you can factor it like that. And what are these numbers? These are the solutions, or these are the x-intercepts. So these are the x-intercepts. These are the x-intercepts, or the solutions of the equations. Okay, or the solutions of the equations. So these are also the solutions of the equation. So solutions of the equation ax squared plus bx plus c equals 0. And then if you look at the graph, since these are the intercepts, what happened? So the graph can look like this. So it's gonna pass through one solution and then pass through the other solution. So those are the 2 solutions. So that is one solution, the smaller one, and that's the larger one. So this is 0, and that's the x-axis and the y-axis. And what is this x-intercept? The y-intercept. Y-intercept is simply the c value. That's exactly the C value. So that means if you know this R1 and R2, you can actually graph this very easily. And then we assume that, so there are a few things to worry about because we know this is like open up. So we know that fx equal a x squared plus bx plus c is a parabola. So it's a parabola. And then we know that it is opens up. So if a positive, what happens is opens up, or what we normally call concave up. And then if a is negative, this opens down. So opens down. This opens up and opens up. So we assume that here a is positive. That's why we write opens up. So that's what happened in the parabola, so that when you can factor out. So the interesting part is, since you know those two solutions, you can directly graph the parabola. Just put the two values R1 and R2, and also C is the intercept, because when you apply x equals 0, you get Z. That always goes there. So that's the y-intercept in this case. C is the y-intercept. R1 and R2 are the x-intercepts. So there are two solutions. So you can see. So these are the two x-intercepts. So two x-intercepts. So that's what happened in this case. So let's look at the next one. If what happened if delta equal exactly 0? So part 2 is delta, which is b squared minus 4ac exactly equal to 0. If this is 0, then what will happen? The square root term in the quadratic formula disappear. The square root term disappears, so that means there are no two solutions, there's only one solution. Because there are no plus or minus anymore, it's 0. So there is only one. There is only one real repeated solution. Real repeated solution. Let's call it R1. And then you can see that this R1 is simply given by negative b over 2a. The reason is the square root term disappear, so there are no other terms. So it's just the first part. And in this case, what can we do is you can actually factor out. So ax squared plus bx plus c, you can factor out this one as, if you pull out a, it can be like x minus r1 whole thing squared, because it's a repeated factor. So we normally call these kind of things a double root. So this is a double root. So this is a double root. We also call multiplicity 2. How many times it multiplies? It multiplies 2 times. So sometimes we, in general, we call it a double root. It's a double root. So how the graph looks like in this case? So you can see that. So what happened in the graph? Because there's only one root. So that means it cannot cross more than 2 times. It can only cross 1 time. So that means the graph gonna look like this. So it's gonna go there and it's gonna touch and come back. So that's what happened to the graph, and that's exactly the C value again as before. That's a C value, and that's exactly the R1 value. So there's only one x-intercept. There's a one x-intercept. So that's what happened, and we also assume that a is positive in this case. If a negative, is going to go backward. So that's a 0. That is the x and the y-intercept, y-axis. So that's what happened in this case. So let's look at the next one. So the third case. So if the delta b squared minus 4ac is negative, so what happened in this case? It's a negative number. So that means you cannot find a square root of a negative number, because it's not going to produce any real number. So what happened in this case? There are no real solutions. So you can see there are no real solutions. So there are no real solutions but has uh, and have and actually has two complex conjugate solutions. These are what we call complex conjugate, and has two complex conjugate conjugate complex conjugate has two complex conjugate solutions. Complex conjugate solutions, we normally write them as alpha plus or minus beta I. That's the kind of standard way to write it. We use alpha and beta to write the complex solutions, and what is that I? This I is, we write as I squared equal -1. That's how we define the I. We define I as is something what we call imaginary. This is how we define it. When you square that, you get a -1, and you can see that that cannot happen in real numbers. So we say it's complex numbers or imaginary numbers. So if you are not familiar with complex numbers, what you can do is there's a link in the description for basics of complex numbers. So you can look at that first before you deal with some complex numbers. So you can find the link in the description for basic complex numbers. Okay, so in this case, as before, actually, what will happen to the graph? So if you look at the graph, and you can see that that cannot cross the x-axis, because if we cross the x-axis, there will be solution. So that means the graph gonna look like this, gonna go and come back like that. So that means never cross the x-axis. So that's what happened. But c is still the same. So that's the c value, but it so you can see the graph lies above the x-axis or below the x-axis depending on the situation. So that's the x-axis. So what happened if the graph lies? So you can see parabola. So parabola lies above. We assume a positive. We assume positive above the x-axis. So if a negative is below the x-axis, that's what happens. So and then you can see there are no x-intercepts. There are no x-intercepts. So that's what happened in this case, because if there's x-intercept, that's a solution. If there are no solutions, mean there are no x-intercepts. So that's what happened to the graph. So earlier the graph crosses the x-axis at 2 times, and then when the discriminant is 0, the graph crosses the x-axis only once, and this time what happened, the graph does not cross the x-axis. And then factorization still works. Like for example, you can write the factorization like this. So ax squared plus bx plus c equal a times, as before, x minus r1 and x minus r2. So what happened is, so these two, this x1 and x2 are the alpha plus or minus beta I. These are not real. So these are not real. These are not real. So that means no real x-intercepts. Okay, that's why you can, so no real x-intercepts. Good. So that is the those are the 3 cases of the quadratic formula. So depending on the situation, you're gonna get different answers for this one. So again, if you are not familiar with the complex numbers, you can look at the link in the description to learn about basics of complex numbers. So if you are not familiar with the complex numbers, so you can look at the you can learn about the basics of complex numbers. You can find the link in the description. Okay, let's solve some problems now. Example, solve using the quadratic formula. So let's look at the first example. So let's say we have 2x squared minus x minus 3. The first thing we do is, if you first check whether it's in the standard form. If it is not in the standard form, you have to write it in the right form, because ABC has to be in that form. And in this one, you can see it is in the right form. So you can see here a equal 2, b equal -1 and c equal -3. So let's look at discriminant. So discriminant which is delta equal b squared minus 4ac. So we're going to plug in here. So if you plug in, you're going to get -1 squared, because b equal -1 minus 4. A is equals to 2 and c is equal to -3. So if you simplify, you're going to get 1 plus, you can see negative positive, you get 24. So if you add, you can see that you're going to get 25. So you're going to get 25, and you can see which is positive. So that's the interesting part. So which is positive? Positive means there are two real distinct solutions. So you can see there are, so that's a characterization. So there are two real distinct. There are two real distinct solutions. And you can get them by the formula. I can see given by. So you can write the formula, so which is negative b plus or minus b squared minus 4ac square root over 2 times a. So we're going to plug in here. So if we plug in, you're going to get negative b equal -1 plus or minus b squared. So actually b squared minus 4ac we already simplify, but I'm going to plug in that value again because that's how we normally do a problem. So a equal 2 and the c equal -3 square root over 2 times a equal 2. So that means if you simplify, you're going to get negative, so it's going to 1, and plus or minus, you're going to get square root 25 over 4, and you can see that this is 1 plus or minus square root 25 means 5 over 4. So what we can do is we can write the two solutions separately now, one with a plus sign. So you can see x equal, the first one, 1 plus 5 over 4. So if you simplify, it is 6 over 4, which is 3/2. That's the first solution. Or the other solution, go with the minus sign, x. So 1 minus 5 over 4. That's the second solution. So this one is -4 over 4, which is -1. So that's how you get the two solutions using the quadratic formula. So let's look at the next example. We can actually graph the solution now. So the graph, so we can see, because we have two solutions. One is -1, the other one is 3/2, and then also we know that the a in this problem is 2, which is positive, so this opens up. So that means we can we have the graph going like this. So x-intercept are -1 and 3/2, and the y-intercept is -3. So you can use those information, x-intercept and the y-intercept, to graph the function quickly. And let's look at the next problem. So this is the next one. We have x squared plus 6x plus 9. So we have in this problem a equal 1, b equal 6, and c equal 9. So the discriminant delta equal b squared minus 4ac. So we plug in, you're going to get 6 squared minus 4 times 1 times 9. You can see that you're going to get 36 minus 36, so which is 0. So since this is 0, there is only one real repeated solution. So there is one real repeated solution, which is given by x equal -b over 2a, because there's no square root term, which is negative b equals 6 over 2 times 1, which is negative 3. So that means if you look at the graph, what's going to happen now is you can see the graph gonna so there cannot be two roots. There's only one root, and the intercept is 9. So the graph gonna look like this. Gonna go there and then touch and come back. So that's the shape of the graph. That is the y-intercept 9, and that is the x-intercept, which is negative 3. So that's how the graph gonna look like. So you can get a lot of information from this one. So the graph gonna look like this. When you have real repeated solutions, it's gonna touch the graph at one point. So let's look at the last one. Actually, next one. So let's say we have C. We have 2x squared minus 4x plus 9 equals 0. And you can see that A equal 2, B equal negative 4, and C equal 9. So if you look at the discriminant, b squared minus 4ac, so you're going to get negative 4 squared minus 4 and then 2 and 9. And if you simplify, you're going to get 16 minus 72, and which is negative. So this actually is going to be negative 56. So it's a negative. So that means there are no real solutions. So there are no real solutions. There are no real solutions. So the solutions are simply given by the formula. So we're going to plug in here. B squared minus 4ac square root over 2a. So if we plug in, which is negative 4 plus or minus, this is we simplify this one. This is negative 56, and over 2 times a means 2. So what we're going to do, we're going to write, so this is a 4 plus or minus. You can write 56 using complete squares, and you can see that you can write 56 as it is 4 times 14. So if you do that, and then once you take the square root, so what you can do is then how to simplify the negative 56. So we can write this negative 56 as like this, or negative 56. You can write this one as 4 times 14 times I squared. So whenever you have a negative, we can write this one as I squared. Now you can take the square root. Once you take the square root, so what will happen, again, square root of every term. So that means you can write this one as square root of 4 means 2. Square root of 14 we write square root of 14, and then square root of I square we write as I. That's the complex unit divided by 4. And if you simplify, you're gonna get 2 plus or minus, and we're gonna cancel the 2. So you can get 14 square root I divided by 2. And we cannot simplify this further than that. So that's the solutions. And if you look at the graph gonna look like this. So what happened is as there are no real x-intercept, that means the graph cannot cross the x-axis, so it's going to go down and go up like that, and that is the intercept, which is 9. So that is that value. So how to get that value? That value is simply 2 divided by 2, so it is 1. So this value is 1. Okay, so that's the shape of the graph, and this is how you're going to get the solution for that. As the last problem of this type, let's look at this one. So we have 1/2 x squared plus 3 equal x, and you can see that this is not in the standard form. So first what we do is we're going to bring it to standard form by moving x to this side and moving 3 to the right. So we write it like that. Now this is standard form. Actually, you can just work with this problem, this equation like this with a taking 1/2, but you can make this equation much simpler first by multiplying by 2. You can always multiply or divide by a constant other than 0 any equation to make it simple. So that's what we do, just to make it simple. But there's no problem working with this one. You can do it, but it will be difficult to work with numbers. So what we do, we're going to simplify it we're going to make it in a simple form. So multiplying by 2, so multiplying by 2, we can write this one as x squared minus 2x plus 6 equals 0. So you can see this is the exact same equation, but in you just multiply by 2 to make it simple. Now you can see it's very easy to work with. So here you can see that a equal 1 and b equal negative 2 and c equals 6. So we're going to plug in this one. The solutions are given by x equal as before, negative b plus or minus b squared minus 4ac square root over 2a. So if you plug in negative 2 plus or minus b squared, which is negative 2 squared minus 4, a equals to 1, c equal to 6 square root over 2 times a equals to 1. So if you simplify this further, you're going to get 2 plus or minus, you're going to get a negative 2 squared means 4, so you're going to get 4 minus 24 square root over 2, and then you can write this one as plus or minus, you can get negative 20 square root. Now this is a very similar as what we did before. We can write a negative 20 as 2 plus or minus, you can say this is 4 times 5 times I squared square root. Now taking square root of each term, you're going to get this one as 2 plus or minus 2 square root 5, and I squared means I over 2. Now what you can do is you can cancel the common factors. So 2 is a common factor. You can cancel 2 from each because you can only cancel common factors. And if you are confused about this one, you can look at the illegal math video that explains what you can do and what you cannot do. So after you simplify, you're going to get 1 plus or minus square root 5 I. So that is the complex solution. So we have a complex solution in this one. That's a solution. So these are complex solutions. Complex solutions. Okay, so let's do one last example. It's a different type of application. So let's look at that now. So let's look at this problem. So what it says that find the values of k such that the following equation has exactly one. That's the important part. Exactly one real solution. Exactly one real solution. So we can look at the problem x squared plus kx plus 3 equals 0. So you can see this is a quadratic equation, but k is not a constant. It's a constant, but we don't know the value. So what we're trying to do, we're going to find the values of k such that there's exactly one solution. So the best idea is look at the discriminant. So for this problem we know that, so the answer, so we can see a equal 1, b equal k, and c equal 3. So we know that for exactly one real solution, okay, for exactly one real solution, we know that the discriminant delta, which is b squared minus 4ac, has to be 0, because when it is 0 there's only one solution. So we can set it equal to 0 and solve for k. That's what we're trying to do. So that means delta, which is b squared minus 4ac, we're going to plug in. So b equal k, so it's k squared minus 4, a is equal to 1, c is equal to 3. So that means you're going to get k squared minus 12 equals 0. Now what we're trying to do, we're going to solve this equation. So we're going to start with k squared equal 12, k squared minus 12 equals 0. So this says that k squared equal 12. So k equal plus or minus square root 12. So now 12 you can write as, we know that is 4 times 3. So that means if you write it, you're going to say plus or minus. So you're going to get the square root of 4, which is 2 square root 3. So that means for those two values, you can see that there's exactly one real solution. So that's how we solve the problem. So that's about the how to solve quadratic equation using four major methods. And then in a separate video, we talk about the applications of quadratic equations, how you can use the quadratic equation to solve some real world problems. So you can see that in a separate video. Okay, and also you can find some practice problems in a different video. Okay, so that's about that. Thank you.